A further example for inverse functions is we look at a truncus here. So we have a truncus again. What we've got here is a restriction on the domain, but if we just concentrate on the truncus at the moment without any restrictions, then we should be able to see that we have a vertical asymptote at x equals 2. And we have a horizontal asymptote at y equals 4. Has there been any reflections of this truncus? There is no minus sign, so truncus will look like this. Okay, so what I'm drawing here is just the truncus without any restrictions. So the test that we've learned so far is it a function? Well, if we do a vertical line test, and we can see clearly that this is in fact a function. However, if we do horizontal line test, and we put a horizontal line through this function, does it only touch at one point? No, it touches at 2 points. Therefore, this is not a one-to-one function. So therefore, an inverse will not exist for this function unless we restrict the domain. And that's what's happened in the question here. You see, we have a restriction of the domain so that we can change the domain of the function. We'll change it to be a one-to-one function. So at the moment, you see, it's not a one-to-one function, clearly. So what we have to do is we have to then change this function. So if we look at the domain that we're given here, the domain is starting at a and going up to infinity. So because it's going to infinity, what we're going to have here is the function, to make it a one-to-one function, you see, it's going to be this bit of the function, right? Because that's the bit that's going up to infinity. And what we're therefore going to do is we are there going to lose this part. By losing this part of the function, then it is a one-to-one function now. So the value of a, now this is saying, again, this is saying the smallest value of a. If it doesn't say the smallest value of a, you would have to accept any answer that's 2 and bigger. So it could be like 3, 5, 10, could be 100. It would still be a one-to-one function if you cut it from 100 to infinity. So this is why the question's saying the smallest value of a for an inverse function to exist. In this case, a would be equal to 2 then. Now, you'll notice here that in the domain it doesn't include that value. Okay, so because the graph can't include 2. Alright, so that's the first question answered. Now, find the inverse function. So now it is a one-to-one function because we have this domain of 2 to infinity. It is an inverse function, so we can find the inverse. So again, what I would suggest that you start with is write down what the domain and what the range is of your function that we've got here. And therefore, from that, we can work out the domain and range of the inverse. So the domain of the function is 2 to infinity, as stated in the question. And the range, you see, if we look at the diagram that we've got here, the range is going to be 4, not including, because you have an asymptote at 4, going up to infinity. So therefore, we can see that the domain of the inverse is going to be the range of the original. So they are going to swap. Domain and range here, they swap. So we know what the domain and the range are going to be. And this will help us later on. So working out what the inverse function is. So again, we are going to swap the x and the y. This is the way that we find the inverse. So y minus 2 squared plus 4. So once we swap the x and the y, we're going to make y the subject. So the first thing that I want to do is I want to take away this 4. So it's x minus 4 is equal to 1 over y minus 2 squared. Easiest way to do this is to cross multiply. So when you cross multiply, the x minus 4 and the y minus 2 squared, they can swap places. Okay, it's just a shortcut. So when this is here, this is dividing, you see. So when you bring it up here, it's timesing. And then when the x minus 4, you move that, it's multiplying. So when you bring it down, it divides. Easiest way is just to swap them. So we have y minus 2 squared equals 1 over x minus 4. So the next step would be to get rid of the squared sign here. So the opposite of squaring is going to be square root. When it's an even power, then we need to make sure that we put plus or minus. Take the square root of 1, it's just going to be 1, so we don't need to put a square root around that. And then the square root of x minus 4. And then, final step is to add 2 to both sides. So we're going to have 2 plus or minus 1 over the square root of x minus 4. Now again, you'll notice here, just like we did with the quadratic, we've actually worked out 2 inverse functions. So, same theory here, the best way to do is just look at what the range is. So what is the range of your inverse function? Well, the range is 2 to infinity. So if we look at the function we've got here, if you want to get values between 2 and infinity, are you going to do 2 plus this value here, or 2 minus this value here? Now, because you have a square root there, this can't possibly be negative, so it's going to be a positive value. So obviously, to get values between 2 and infinity, you've got to do 2 plus 1 over the square root of x minus 4. Okay, and that's going to be your inverse function. So to write this out properly, state the name or domain that we can get from here. The domain is 4 to infinity. Okay, you can always check what your domain works here, you see. So for this function to be undefined, you see here, x minus 4 must be greater than 0. It can't be 0 because it's on the bottom, it's under the square root, so it can't be negative. And then you see x must be greater than 4, which is in fact the domain that we expected. So you can always double check your answers and make sure that you haven't made any mistakes throughout, you know. And we just write down what the function is here. So 2 plus over square root of x minus 4. Okay, so again, for these type of questions here, you have an asymptote at x equals 2. So that means that on the inverse, you're going to have an asymptote y equals 2. You have you have y equals 4 here. So in the inverse, it's going to be x equals 4.